Good afternoon, everybody. My name is Marek Michalewicz. I'm the director of Interdisciplinary Center for Mathematical and Computational Modeling, University of Warsaw. We've been running this series of virtual seminars on computer and computational science for a while now, over a year now. And we are very, very fortunate to be able to invite the most prominent, very interesting personalities from this wide era of computer science, computational science, including, of course, today's speakers, Professor Andrew Turpin from the University of Melbourne. Before introducing Professor Turpin, let me say a few words, typical words about the ICM, and not so much about ICM, but about what we do, what is really quite exciting for us. The most exciting news is that we will be running 7th edition of Supercomputing Frontiers Europe 2021. The dates are July 19th to 23rd. The call for papers is open, so I encourage everybody who knows anybody in this field and who might have interest in presenting at our conference. You are all most welcome. Please consider. As usual, we are planning for extremely interesting lineup of keynote speakers and invited speakers. There will be topics covered in HPC, of course, in artificial intelligence, quantum computing, and all the related fields. So that's going to be very, very exciting. And I need to acknowledge our sponsors. Our virtual ICM seminars are sponsored by International Information Processing Institute in Poland, and we have several media partners, Datanami, ITWIS, HPC Wire, Computer World, Enterprise AI, and Forum Akademickie. Some of you might have experienced few of our seminars. All our seminars are recorded and available widely, open to anybody who has interest in those topics, and I can assure you that the scope, the topics presented so far are really fascinating. And we had people like Stephen Wolfram, the creator of Mathematical, and Edelman, creator of Julia Hiraoki Kitano, who started this RoboCop soccer tournaments and is creator of Systems Biology Institute, and so forth. Many people. You have the list here, great people. And of course, today I have a really great pleasure of welcoming Professor Andrew Turpin from Melbourne. I need to say, as a side note, that Melbourne is my sort of most favorite city almost in the world. I know Melbourne better than Warsaw, for sure. And I lived there for over 30 years, on and off. And Professor Turpin is a senior academic convener, Petascale Campus Initiative lead, and leads this Melbourne Data Analytics Platform, and that would be main topic of Professor Turpin's presentation today. Professor Turpin has wide research interests around applications of algorithmic efficiency to problems such as data compression, text search, analysis of political text, human vision testing, and modeling of the human vision neural pathways. As a side note, I say that several of those topics are intensely pursued also by my colleagues at ICM. So these are extremely fascinating topics. But for the last 2.5 years, Professor Turpin has been charged with establishing the Melbourne Data Analytics Platform, a group of academics who specialize in supporting research of others with cutting-edge data analysis and computational techniques. Formation of this workforce is also part of a wider initiative at Melbourne to boost HPC, cloud, and data management infrastructure for research, for which Professor Turpin is the academic lead. Prior to working at Melbourne, Professor Turpin worked at RMIT University in Melbourne Curtin University in Perth, Australia, and Oregon Health and Science University in Portland, USA. And before embarking on the scientific career in computer science, he worked for several years as a trainee actuary with Swiss Re Australia. So that's a very brief bio. And with this, I won't be talking about expanding on the topic of Professor Turpin's lecture, but Professor Turpin, the floor is yours. Thank you.
Thanks very much, Marek. Thanks everyone for attending. So just before I launch into the talk proper, let me just tell you what about Melbourne. So if you type Melbourne into Google Maps, it'll probably show you Melbourne, Florida, which is not where I'm from. I'm from Melbourne, Australia, which is down here. Melbourne University itself, it has old buildings, it has beautiful new buildings, it has some pretty terrible in between buildings, so it's a typical university campus in some sense. Here's the sort of corporate spiel about the size and rank. You know, we're a research-intensive university. We have a lot of undergraduates, masters, graduates. We had a very high degree, a high proportion of international students until the beginning of, or until March 2020, when we closed our borders. So that figure's probably not current anymore. But perhaps most importantly for the talk today is that we do a lot of research in a lot of different areas. So we have 10 main faculties: law, medicine, arts, science, engineering. So a comprehensive university covering lots of disciplines. So that's sort of Melbourne University. That's where I'm coming from. So the talk today, similar to Warsaw, I think, in many ways, in sort of scale and research focus and the like. So the talk today, it will be about how we're supporting research, compute and data, digital needs for research. We have research platforms. So Valerie, those of you who listened to Valerie's talk the last talk in this series from UC San Diego, would have heard about research platforms, would have heard about the problems and solutions that San Diego have gone through. Melbourne is no different, and many universities around the world are no different in that regard. And so I was nodding along to Valerie's talk, going, yes, we have that problem, yes, we have that problem, yes, we have that problem. We've taken a slightly different approach with some of the solutions, and that's what I'll talk about today. So I'll very briefly talk about the research platforms, very briefly spend 5 or 10 minutes on this Petascale Campus Initiative, which is a big sort of all-encompassing plan, and then I'll drill down to focus on, in particular, this Melbourne Data Analytics Platform, which is a workforce component of the plan. So just to sort of set the scene, the computing at Melbourne, I got involved in this in 2018. So prior to 2018, what did we have at Melbourne? It was a bit of a mess, really. We had a blue gene for life sciences, so a lot of bioinformatics was being done on an on-premise blue gene machine, which we shared with a couple of other universities in our state. But in general, and I'm sure this was the same, is still the same, or maybe some universities are returning to this, but there was server rooms all over the place. There was clusters under desks. There was, homemade clouds in people's offices. There were high-end workstations attached to microscopes. There were, a fancy server attached to an MRI. There was machines all over the place, doing all sorts of things, wasting mountains of cooling and electricity and breaking down and etc. But, it worked, and people were generating research results. We have some national facilities. So Australia-wide, we have the National Computing Institute Initiative. Oh, not quite sure what the I stands for now. And so 2 national supercomputer facilities. And of course, there's the commercial available. There's Amazon, Azure, Google, etc. And prior to this Petascale Campus thing, mainly the support staff for DevOps, sysadmins, those type of people reacting to problems, fixing problems as they arise. There was no overarching strategy about how compute should be organised, how data should be compute research data should be organised. Of course, there was an enterprise strategy, right? So the student records and finances and everything, that the enterprise IT was taken care of in a corporate sense, but the research infrastructure had no overarching strategy. And the idea of these platforms were emerging. I'll talk more about them. So fast forward to, or rewind, or however you want to think about it, to 2018, the Petascale Campus Initiative was funded, a 5-year program to coordinate and build on-premise HPC, high throughput as well, and cloud, make sure it was integrated with the national and commercial providers and international as well. Organise and support data management for research, build a workforce that could help researchers make use of this infrastructure. And all of this was being done from an academic leadership point of view. So it was being driven out of the Deputy Vice-Chancellor of Research, so an academic lead and very much with an academic flavour, I guess. Of course, the actual delivery of the infrastructure has to be done by professional staff. You don't want academics getting anywhere near that. But the leadership and the vision, etc., was very much academic driven. So I'll go on to talk a little bit more about this 5-year plan. But first, let me just take a slight detour into platforms, which is another form of research infrastructure that we have. And Valerie mentioned that San Diego has similar things. So what's a platform? It's just an organisation, perhaps 1 or 2 people, a technician and a manager and a piece of equipment is typical. But that piece of equipment generates a lot of digital data, right? So something like an MRI or soil analysis, X-ray diffraction, things like this. And so it's a service operated that researchers on a user pays kind of basis. And so Melbourne has got 23 of these, just listed here. There's a URL for those interested. You can go back later and have a look. The ones on the left here are all based around a particular technology, something like histology or microscopy, etc. The ones on the right, if you look, there's something called the Melbourne Statistical Consulting Platform. So this is not based around equipment. This is based around a capability. So their main role is statistical advice for graduate researchers, for PhD candidates. There's a software engineering platform. So again, researchers who know they need an app, they need a web application, they need a piece of software, they can go to this platform and get that piece of software built. There's a bioinformatics platform, blah, blah, blah. The 2 down the bottom here are the ones of most interest for me in this talk, and that's the research computing infrastructure, the HPC and cloud, and the Melbourne Data Analytics Platform, which I'll talk about some more in depth. So that's the platforms, and they're sort of these little units that exist with a specific function. They're not a general purpose kind of facility. So jumping back to this Petascale Campus Initiative. So, I was maybe and still am in some sense a classic academic, traditional academic. So maybe 5 years ago, if someone had have put this red sentence in front of me, what's the goal of the PCI? It's easy for our researchers to use large data and computing in impactful research, right? So 5 years ago, as a cynical academic, I would have, well, this is usual chancellery rubbish coming from, corporate headquarters, a pithy slogan, and, it's not going to amount to anything, blah, blah, blah. But now, of course, I'm on the other side of the fence. I'm actually coming up with these pithy slogans and having to defend them in some sense. So let me try and defend this claim to you. So by the end of 2022, this is what we want to claim, but this one sentence contains a lot of complexity. So first of all, the word easy, right, it can be interpreted in many different ways. And so let me just get a pointer here and so the word easy, it means many different things to different disciplines, right? So easy for a physicist is, well, I want my custom hardware and software for my astrological simulations or my synchrotron data or whatever it is. For a medical researcher, easy might mean I can comply with privacy and security regulations for my data. For a humanities researcher, easy might mean being able to publish some primary source material on the web. So the word easy can be unpacked in many different ways for many different disciplines. And so the staff required to support this concept of easy have to be able to collaborate. Valerie used the word facilitator, I think, in her talk. So they have to be able to facilitate, collaborate, introduce, translate, and things like that. So that's the first part of this statement. Data and computing, so that's we can probably guess pretty much, this audience can guess what that means. We need a lot of storage, petabytes of storage, hence the Petascale Campus. That'll probably be out of date soon. We'll have to update that. But luckily, the Pedestal Campus only goes for 5 years. We'll be on to exascale, I guess, next. And we need computing capacity, whether we have that on-premise, whether we use the national facilities, whether we use international facilities. We need access to either a lot of cores or a lot of cores that are connected in special ways to make supercomputers. We have to be able to move data around. So we also need, and Valerie spoke about this as well, the network infrastructure to move data around, etc. And the staff we need for this piece of the puzzle, we need technically excellent staff. We need sysadmins, DevOps, engineers to build, create, and maintain this. But we also need the staff to have I haven't written customer focus, and I would never say such a thing because I'm an academic, but you can't just have technical expertise. You also need to have staff who are going to make sure that the infrastructure is aligned with researchers' needs and can be used. And we need different organisational structures for that to happen as well. There's an entire talk about that in itself, so I won't go there. And finally, of course, you have to have the word impact these days when you're talking about research, but to try and actually make that meaningful, I think what that means is you need engaged academics, right? You can't measure impact in an abstract with abstract metrics. You can't, citation counts, grant dollars, all that sort of stuff. It's not really capturing impact. Well, it's capturing bottom line impact, I guess. But, in terms of social impact of research, you really need peer review and panels of academics and academic input. So academics have to be engaged somehow in this enterprise. It can't be left to professional staff to do all of this because they don't have the experience or the academic judgment of impact. They could learn it, but that's not their role. So all of this one sort of pithy, catchy statement explodes into a very complex situation. We've reduced it to 4 main programs of work. So the research data management program of work, which again, another entire talk in itself, building some infrastructure, different talk, and a whole bunch of leadership activities to get academics and professional staff to engage and work in partnership. Again, another talk. The workforce will be the focus of this talk. I'll just say one last thing about this whole initiative before I move down to the Melbourne Data Analytics Platform, and I guess the sort of a message or a reflection by us, and you can ignore it or embrace it or attack it as you see fit. One of the keys to us in this sort of enterprise has been to embrace complexity. So this is kind of, there's two diagrams here. The one on the left was what we drew in 2018 when we set out on this initiative. We had this beautiful, clear diagram. You know, we have governance up in the top right, we have researchers in the centre, we have the services on the left, and we have this new workforce we're building, and everyone's connected and happy and communicating, and it's all simple and clear. And, you know, that's just not the way the world works. It's a beautiful diagram, and it has some explanatory power, but we sat down. We realised quite early on that this is a complex system, as in a formal definition, right? There's lots of actors, there's lots of connections between the actors, there's emergent behaviour from the system that you don't expect, there's feedback loops, there's non-linear, you know, that your inputs don't match your outputs in a linear kind of way. It is a complex system. And we played around with this diagram on the right, is a recent one using it's a causal loop diagram, which is a tool to try and understand a complex system. It's far from complete. We just sort of played around with it one day and see where we got to. But you can see that it attempts to elicit some of the complexity, and there's things you can do with these diagrams. But anyway, it's a complete another talk about how we evaluate the success of this initiative. Do we get to the red goal in such a complex environment? How do you go about evaluating that? And so that's another talk again. So that's enough about that sort of stuff. Let me move on to the workforce. So within this complex environment, we're building infrastructure, we need academics involved, we're putting in place new research data management policies and systems. One piece of the puzzle are the facilitators, the on-ramp, the translators, i.e. some people who can help researchers make use of this new infrastructure. So, you know, there's the existing users, physicists, some of the scientists, some of the engineers, a couple of the medicos, you know, bioinformatics. They're already making use of this technology, so they don't need help. They just need more money and more cores, right? But there's a lot of others who know that they should be or want to be using this technology, or are stuck with their existing technology and are not sure where to go. You know, they've run out of storage on their laptop, or their laptop's overheating when they try and do their simulations or whatever it is. These people need help. So we looked at other Australian universities. So Sydney University had a group, you know, like this. There was a group in Queensland, up in the north, that were doing this kind of thing. We looked internationally, University College London, the Moore Sloan Initiative in the United States, Zurich, a couple of places in Germany, right? There's lots of places around the world, universities around the world, also trying to build this kind of workforce. So it was obvious that it was needed, and I'm sure at your universities, it's exactly the same, right? And we saw it's the same at UC San Diego. So in this sort of complex environment, we need this workforce. Another piece of information here is that at Melbourne University, at many universities, there's sort of two workforce categories, right? There's the academic staff that do the teaching and the research, and there's the professional staff or their administrative staff of different kind of names who do the HR and the finance and the enrolment and all that sort of stuff. At Melbourne, there's a third category called academic specialist, which is an academic who specialises in one particular area. And this was created in particular for academics who wanted to pursue a teaching-only track. So they wanted to specialise in teaching. And so you can still get promoted through the academic ranks to professor, but only in teaching. And so we looked at this and we thought, well, why don't we have one of these academic specialists for this research support role. So we called them research data specialists. And so we began thinking, okay, we've got the ability to have this work category, but what does it actually mean? Who do we need to recruit? Well, of course, we need very smart people who understand the research game. Many of you are probably researchers yourselves, and if not, you've certainly interacted with researchers. You know what happens if you put someone a fool in front of a researcher. They're not tolerated at all. So you need smart people who understand research. They understand the business of research, the processes of research, but they also understand the motivations, right? Why are you staying up till 4 a.m. to finish this paper for this deadline, right? Why are you putting in this grant where there's only a 1% chance you'll get the money, right? What are the motivations of researchers, etc.? So that's kind of a given and kind of obvious. They need to be flexible because we're going to be asking them to work with a variety of disciplines. We're not expecting them to be embedded in one particular discipline, because then that just becomes another member of that faculty staff, right? We want to create a team and leverage the team environment of multiple skills and multiple backgrounds. These people have to be risk tolerant, right? So they have to accept some personal risk to be involved in this enterprise, right? This is a new workforce we're creating. This is a bit of an experiment in Australia, at least. No one's done it. And it's a bit of an experiment worldwide as well, because most of these undertakings are done under the category of professional or administrative staff, not as an academic unit. So personally, they have to be ready to take the risk. But also, as you all know, research is a risky business, right? You can spend months working on a theorem, lemma, proof, and only to find that it wasn't as great as you thought it might have been. You can spend months trying to get a program to work, and it just doesn't. The brilliant visualization of the growth of visual neurons that you work on for 2 years might never get published. That would be me. So, it's a risk. They have to be tolerant to risk and resilient to rejection and failure. And of course, they have to be great communicators, because we're asking them to bridge a gap between technical staff, DevOps, sysadmins, the world of HPC, instance, words like instance, volume storage, etc., mean nothing to your history professor who wants to put their things on the web. So this is the people we need. Everyone needs these people. These are the golden employees, right? Industry wants these people. So what can we offer these people that industry can't? We can't offer them money, right? And again, many of you are academics, and I'm sure you're not in it for the money. What can we offer? Interesting challenges and interesting problems, right? Cutting edge problems, cutting edge solutions, variety, collegiality, a career pathway. Basically, we can try and offer them an academic life to lure them away from industry. So that was the thought. How did we go about? Oh, sorry, I forgot about it. There's another key question here, and this comes up a lot actually when you start talking about this space of research support, and that is recognition. How are these people, if we employ them in this kind of capacity, how are they recognised? And so what that really translates into is how are they going to get promoted, right, as academics? So for traditional academics, you write some papers, you supervise some students, you bring in some grant dollars, and people go, yeah, okay, you can climb the academic ladder and you build an international profile and you become a world expert in something, and okay, you can be a professor, that kind of thing, right? But if you're supporting research rather than initiating your own research, that recognition doesn't follow, right? You're not going to be, as a supporter of vision research, if you like. I publish a lot on vision research, and I do a lot of computational research related to vision, but I'm never going to be asked to give a keynote at an ophthalmology conference because I'm a computer scientist, right? And so we had to search for ways to get these people recognised and to get them promoted? What are the KPI? What are the promotion criteria? What's the recognition criteria? And they're listed here. You've probably read them by now because I've been rabbiting on, co-authorship of papers. So, or even acknowledgement. Doesn't even have to be authorship. And, we're not expecting first authorship or last authorship, buried somewhere in the middle or acknowledged. Perhaps named as an investigator for a grant, but perhaps not even named as an investigator, perhaps written somewhere in the body of the text of the grant, we'll be using MDAP for data science or something. Co-supervision of students, but again, no expectation that they would recruit their own students, no expectation that they would set the project for PhD students, I'm talking here, but they could easily co-supervise. And then there's, testimonials from satisfied customers, in inverted commas. My research couldn't have been done without MDAP, etc. And then perhaps the final one here, perhaps they're allowed to do their own research. I'll come back to that at the end. So we know the type of people we want. We've got a plan on how we make a career structure for them at the university. Now we just need to do the hard bit of actually finding them. So step one, we need to convince the people who hold the purse strings, which at our university, the deans of the faculties form the university executive, along with the vice-chancellor and a couple of others. But basically we have to convince each faculty's dean that this is a good idea. Why should they be paying a premium for this academic unit, right? If you want a data scientist to solve a problem, you can hire them for 6 months and, on a low wage, you might get the job done, you might not. You might get some software written, you might not, and then they leave because the pay is low and they go and work for some consulting company and earn double the money, right? So we're going to be paying a little bit extra in terms of allowing these people some academic freedom. They're not going to be working on your research problems 24/7. They're going to be talking to each other. They're going to be authoring papers. They're going to be researching methods that they might need. So there's a little premium there. How do we convince deans that this is a good idea? And so, it's unique, it's leading, it's visionary, it's innovative, all those type of things, which, it is in Australia at least, and there's a pretty good case that it is for the world as well. But also there's the straight out, if you're talking to a number cruncher or a bean counter, there's the straight out economic arguments, right? Where if we can retain these staff at the university, then you avoid recruitment costs, you avoid staff turnover costs. The economy of scale and scope from having a team that can tackle these problems also exists. So there's plenty of good arguments, I think, of why this is a good idea, and they must have been okay because the deans all agreed and said, okay, we'll fund this for 3 years and see how it goes. So then we split the recruitment into 2 phases. The first phase, we recruited internal to the university only. And this was sort of a deliberate strategy to, get people who already knew how the university worked, but also they could bring their networks of researchers with them. And these were postdocs predominantly, a couple of professional staff. They'd finished their PhD, they worked as a postdoc for a while, then they'd worked as professional staff because they weren't really sure they wanted to be independent researchers. And then they saw this Melbourne Data Analytics Platform thing. They went, oh, actually, that's the kind of academic career I would like. And so they joined us. So we picked up 5 or 6 people. We gave them agency to build how the team should look. And, I'm too old. They're young. I don't know what they're on about. They say that Twitter's important. It's like, really? I don't know. I guess if they say it's important, good luck to them. So we gave them some agency to set up processes and governance structures. We decided on a flat consensus-based model, not a hierarchical model, and etc. And all of this was overseen by the academic director, myself, and a group of academic steering committee people who were committed to the idea of this MDAP. And then the second phase, once we ran a round of projects and collaborations with these people, we got our structures sorted out. Then we recruited a second wave of people from we opened up and recruited from outside the university, looking to add people with different backgrounds that we didn't have. So we added some history, we added some geography, people who knew Python but were from a PhD in geography, people who knew Django and Docker containers, etc., but they did their PhD in music. So we expanded with those people, and we completed that at the beginning of 2020. So we've been running for nearly a year now with a full cohort of people. And then the final phase now, so initially I said we got 3 years of funding, so this year we need to get more funding. And that's the process I'm in at the moment. So did it work? I think it has worked, but the next series of slides, these are the next few slides are the slides that MDAP themselves use to talk about themselves. So this is MDAP now talking about themselves and what they would say. So you see here, we're a team of academic specialists working to enable blah, blah, blah. See, the collaboration is number one here, right? So this is not a service. This is not your service user pays platform where it's not a transactional arrangement. You don't pay us to write you a Python program. You don't pay us to convert your FileMaker Pro database to SQL or whatever it is. You collaborate with us as a research collaboration. Some of those transactional tasks we do as well. Just sort of on the side, but the majority of our purpose is to collaborate with you to shift your research in a new direction, your methodology, whether it's machine learning, whether it's moving things to the cloud, whether it's optimizing your code, whatever it is. So the main engagement is through collaboration, not service provision. This is our team. There's me. There's our manager. At least one of you will recognise at least one of those other faces. How does the collaboration actually work? We put out a call for an expression of interest call every 6 months, and so it's like an internal grant application. It's very lightweight. We have a panel of senior academics who help us rank the applications in terms of sort of strategic importance to the university. And then we do as many of them. We just work our way down the ranked list and do as many of them as we can. We have to be a bit faithful to our funding masters. So we roughly take 1/3 medicine, 1/3 STEM, 1/3 humanities and social sciences when we can. You're not just getting one staff member to work with you, you're getting sort of the whole team. In some cases that might be one person, in some cases it might be 3 or 4 people have the breadth of skills required. And in addition to actually doing the research, there's also an expectation that when we walk away at the end of the 3 to 6 month project, there'll be knowledge transfer and to the research team so they can carry on, right? We don't want to walk away and then they never use the cloud again. We don't want to walk away and the website sits there and eventually it's defunct. There's a big emphasis on capacity building and knowledge transfer to the research team so that they continue using the methods and growing their interest and skills. The data specialists themselves provide intellectual input, write software, design new algorithms. This is a tricky one. We have to be careful here, right? There's other groups within the university. We're not looking to replicate things that are done elsewhere in the university. So depending how new your algorithm is, we might send you to the computer science department. We might send you to the maths department. We might send you off to the bioinformatics platform. Data analysis pipelines, authoring of papers, introduction and upskilling in new technologies. And that's all kind of obvious, right? That's kind of what you'd expect us to do as an academic unit supporting research. Perhaps slightly less obvious is a group of data stewardship activities. So supporting people with their open scholarship. How do you make your, what open source license do you use? How do you make your data fair? For those of you who know what that means. Where do you put your data? How should you be collecting it? What metadata should you be using? How should you arrange it? What visualizations might you use? And also community building. There are others at the university doing things like you. Let me introduce you. Here's a Slack channel that you can contact us on, etc. So this is what MDAP, this is MDAP talking now. This is what MDAP has learned. So what works well and what's best to avoid. And again, I don't think there's a lot of surprises there for people who've thought about this before, right? Clear communication, time, etc. So now switching back to me as a sort of the meta, back to the meta that was MDAP talking about themselves. Switching back to the meta, what have we learned about this process? If I was to, if those of you who are interested in trying to implement something like this, what are the key lessons that we've learned? And I've been saying a little bit, that I'm representing a group of academics that's been involved in this. You need the full support and sponsorship of your senior leaders. That might go without saying, but it's been essential for us. Having this academic specialist workforce classification has facilitated our approach as well. So, being able to define recognition systems that are perhaps not the same as your traditional academic. Our two-phase approaches worked well. The internal recruitment, I think, really let us hit the ground running. It really bootstrapped the whole process. Careful selection of staff, of course, is crucial. That's the same in any undertaking, really. Having a group of academic mentors has also been very important. So, in addition to myself, I have a team of 3, one from medicine, one from science, one from humanities. And before we came along in 2018 as part of this Petascale thing, there was already a group of academics, one from each faculty, who were thinking about these things. So having a good group of academic mentors has been essential. And of course we have to produce, right? We have to produce results. Depending who you're talking to, depends how you cast the results. Generally, people are very happy with descriptive statistics out of context. So you just tell them, yep, 5 new grants. Why is 5 better than 4? Who knows, right? It's completely out of context, but these are the kind of numbers that people like to see. I think as long as 100 researchers helped, 5 new grants, 12 papers. I just made these numbers up, by the way. Our numbers are probably actually higher than this, but I think it doesn't. There's no context here given. Is 5 good? Is 4 good? Is 12 good? Who knows, right? Well, I could talk about it, but having some results, whether it's quantitative, whether it's qualitative, tailoring the results to the audience. If you're interested in more, then you can go to our website on the address, or you can search. There's a nice glossy brochure that we produced in the middle of last year just to make sure the deans were still on board, and outlining some results. So that's sort of the lessons. Of course, this whole undertaking, and for those of you who are involved in these kind of undertakings will know this, it's like tiptoeing through a minefield, balancing 2 trays of very expensive glassware or something, right? There's a lot of balancing acts. There's a lot of pitfalls and traps and politics. But in terms of MDAP itself, there's a few sort of ongoing things that we haven't resolved, or a continual sort of, not problems, but sort of nagging things we have to balance. And one of the tensions is between training and knowledge transfer. So by training, I mean delivering courses, right? Why don't we just teach everyone all researchers do a cloud course? Problem solved, right? Now they can all use the cloud. Let's do an introduction to machine learning course for everyone. Problem solved. All the researchers now know about machine learning. We've avoided doing that, and one's a very pragmatic reason. When it comes to budget cuts, it's very easy to get rid of training. If we can get rid of the person that teaches Python to researchers, but we can't get rid of the person who's halfway through writing Python code for the researchers. So from a pragmatic point of view, it's very hard to get rid of collaborators. It's much easier to get rid of trainers. That's just a pragmatic decision. But also, I think in terms of bang for buck, we're really trying to focus our knowledge sharing and efforts rather than a mass training. But, it comes up again and again. And it sort of folds into the next point here. How are we helping the researchers who don't know what they don't know? So if you know you need the cloud, if you know you need machine learning, if you know you need high-performance computing, then you can type the right search terms in and you might find MDAP to help you. If you're from the humanities background, you don't have the language to express your needs, right? Your Excel spreadsheet has got too big. Your PDFs have scanned a huge size and don't fit on your hard disk. Or, what do I do? The people that don't know what they don't know, in effect, would probably benefit from this mass training that we're not doing. So again, it's we've had a recent idea about how we might address that. Do we allow these MDAP staff, these academic specialists, to pursue their own research? This is, places like Google brag about, you get a day a week free to pursue your own interests. I'm not convinced this is a good idea. I'm speaking for myself here now rather than my university, I guess. We all hear that research is moving to multidisciplinary teams are now sort of essential to tackle big research problems. So training junior staff to be lab leaders, to be independent researchers, to be solo researchers might not be doing them a service. Having them in MDAP as part of a team doing cross-disciplinary research as co-authors might actually be doing them a service. I don't know. But again, this is a sort of a tension and a thing that we have to sort of resolve. So I might stop there. Hopefully in this sort of rambling reflections, you've managed to take away something of interest. More than happy to take questions, and just quick acknowledgement of I've stolen some slides from various people, and there's the web address for MDAP if you want to go and look up our glossy brochure. Thank you. So there's a question. I'll start addressing the questions in the chat. There's one there. Does the approach also include hiring IT security specialists? We haven't at this point, but I think we might have to. There's already a large cybersecurity group as part of the enterprise. So the student records, the finances, all that sort of stuff has to be locked down. Cybersecurity for research data has been limited to one or two research groups who have employed their own people, but it's becoming, particularly in medical research and clinical research, is becoming more of a problem. Governments won't release their data to us unless we have certain security systems in place. So we haven't to date, but we might have to in the future.
Okay, we have other people busily typing their questions. In the meantime, maybe I will ask you, do you have requests from your research community for access to international data, to resources from outside Australia? So you have to collaborate with ARNet and other organizations.
Yeah, that again, it's kind of a case-by-case basis. I think several research groups are already connected, right? So the astrophysicists have got their international networks, and some of the economics people already have international networks, but we haven't tackled that directly, I guess, other than being flexible and open to the idea.
Yes.
Yeah.
So there are more questions here.
Yeah. So matrix management, I guess, in terms of, I guess you've sort of been the structure of the organisation. We've gone for a very flat structure. So I'm trying to manage it like a academic department. Yeah. So we're kind of outsourcing that decision, I guess, to this committee of senior researchers. So we've got cover in a sense. So we certainly rank what we want to work on internally, and then we put it through this committee of senior academics for peer review. And, you know, there's been some grumpy academics saying, why didn't you support our project? And we'll say, well, sorry, the peer review said that it wasn't as important as some of the others. You know, you just have to have a bit of a thick skin, I think, in academia. As your academic staff become more experienced, would you then consider them doing their own research? Again, that's a good question, particularly for the very junior members. So some of our team have only just graduated with their PhD, and you know, we're very loath to close the door on their traditional academic career, but I'm not sure if we are. I think it's perfectly reasonable that they would pick up a postdoc in a couple of years, and their time at MDAP would be seen as quite valuable, you know, in a multidisciplinary environment. For a very focused, single, solo sort of author kind of discipline, it wouldn't be an advantage. But for multidisciplinary kind of team research, I think it would be an advantage. So, you know, I don't want them to leave. They're a great team, but you know, if they flourish and go on to have a fantastic academic career, then I think that's also a success for us in some way. I mean, we're a university, right? We should be encouraging that. Do you use any software tools to help with data management, long-term preservation? Yes, so I didn't talk about research data management at all. I think that's a completely separate talk, or you're welcome to contact us separately and have a discussion about that. We use a platform called MediaFlux. Preservica, there's a few others. I'm not an expert in this space, but yes, we have an entire long-term kind of strategy, I guess.
And so I don't see. Oh yes, there's a question from P. Bashkevich.
The one that I skipped over at the end. I think the user pays model obviously is politically easier, right? You don't have to go around convincing deans that they should prepay for this service, which is what we've done at the moment. All of the platforms run on an 80% cost recovery model. So 80% user pays, 20% central financing. MDAP is slightly different at this stage. It's continuing to be centrally funded rather than user pays. I think that other than the stability, it really comes down to contracts, right? If the university can underwrite the employment contracts, if you can employ these people for 5-10-year contracts, and the university will underwrite that, and you supplement it with user pays, I think that's the ideal case, right? If you go to a pure user pays model, then you can't necessarily offer these people permanent or long-term contracts, right? So it's perhaps just a sort of an accounting trick more than anything else. What's potential use for groups for different fields? Yep, also a good question. With science, so physics, biology, chemistry have been very heavy users. Law, surprisingly, have been very heavy users with sort of natural language processing and machine learning in inverted commas for law. Medicine have been slow to take part, and some of the fine art has taken part. Economics has been a bit slow, so it's been a bit patchy. I think one of the reasons for that is the way we operate. So we're doing this sort of internal grant thing. So for disciplines that are used to applying for grants, which the sciences are, it suits them very well. For disciplines that are not so used to applying for grants, in some sense, in a sciencey sense, perhaps they're not quite seeing what we're offering, and so we're doing something to address that at the moment. We're going to change the way we appeal to those faculties. Do you assess your MDAP workers if they're doing the best or maybe slightly over? Yeah, we're using the academic system of evaluating performance at the university, which is an argued case. So each person makes an argued case that their performance has been satisfactory. And so it's up to the individual then what they put in, right? So if they choose to focus on I helped 300 researchers learn Python. Yeah, okay. Or I helped 2 researchers write a Nature paper. Yeah, okay. Yeah, so it's a very flexible argument-based approach to assessing academic performance, which we apply to the MDAP staff as well. Yeah. And also, I think, just as an aside, the type of personality, and most of you know this as well in academics, right? The personality types of people that get involved in academics, they have very high integrity, generally speaking. Of course, there's always bad apples, but very high integrity, very self-motivated, and so it hasn't really. It's not a problem. Generally, you just get out of their way, and they'll do good work. The bottom question about we provide internal cloud services that are much cheaper for us to run than to pay Amazon, maybe by a factor of 2, something like I can't remember the exact amounts, but I think it translates. If you fully cost our internal cloud that we run on premise, it works out to be about half the price of Amazon. But of course, we don't have all of the functionality of Amazon either, right? We don't have glacial storage, and we don't have, we can't burst, we can't infinitely upscale and things like that. We have capacity limits because we run our own internal cloud, but it does work out to be much cheaper than paying commercial providers.
Perhaps I will ask the question while somebody is still writing. When you first introduced the services, have you already had the infrastructure for cloud services ready, or you built it yourself? And then how was the dynamics of uptake? How fast people learn about it, how sort of enthusiastic they were about it. And I'm asking it in self-interest because we are just embarking in that sort of exercise here.
Yeah, I wasn't directly involved in building the infrastructures myself, but they are running at capacity. I think it's a bit like roads. I think the more you build, the more traffic arrives. You're same with data compression of disks, right? The more disk you buy, the more data seems to appear. It's been the same with the cloud and the HPC that we've built. We now have a plan for adding slowly as demand oversubscribes, but we want it to be a little bit oversubscribed. So I think initially existing users took up the slack, but then as the services were advertised and through things like MDAP, people are starting to use it. We're getting a much broader user base. So it's always been fully subscribed, but the difference being that it's now a much broader user base than perhaps it was before.
There's a question here.
Do you feel too much interest, not enough, or just the right current scale? Yeah, this is also another one of the balancing acts as I tiptoe through the minefield, right? If you advertise and get swamped with applications, then there's a lot of disappointed people. If you don't advertise and you don't have enough applications. So I think we're just right at the moment. Just I think by luck more than design. We don't have the capacity. COVID has killed our budget, and all our international students are staying away. So there's probably like many universities, we have to find millions of dollars, hundreds of millions of dollars of savings, right? So if demand grows, there's no way we can expand to meet that demand at the moment. But it's just about right at the moment, and I think that's more by luck than anything. We accept about, so we have 15 odd staff. We accept between 10 and 15 collaborations every month. It kind of depends on the scale. Some of them are very involved, requiring a couple of software engineers. Some are quite small, requiring just a bit of data to be moved around and a cloud to be set up. So we accept somewhere between 10 and 15 collaborations. And then in addition to those collaborations, we do a lot of small transactional stuff on the side.
Okay.
So the percentage we accept maybe 30% of applications. So but it's a bit like any grant system, right? Some of the applications are not appropriate for us. They're more appropriate for other units. So perhaps the 20% tail is not suitable for MDAP. 20% is not particularly interesting, and that leaves 60%. And of that 60%, we would support at least half of them.
And so, how fast is turnaround between the application for support and your decision to support?
I think it's a 4-week process. So we call for the expressions of interest. Then we work with, that's just a very simple 1-page form. We then assign one of our team members to each of those who work, either redirect it to a different service or encourage them to build a full application. So that happens over a week. They put in the full application. It gets sent out to this committee. It gets ranked internally. So it's another sort of internal peer review process for another week or so. And then we make the announcements. So it's probably a 1-month process.
Very good.
All up.
There are more questions.
Yes, that's a very good question. The university has pricing policies for external consultants, but that's slightly different. For internal use, I have made an arbitrary kind of decision saying, well, about the middle of the academic salary range, because you're getting sort of a variety of expertise and a variety of academics at different levels. I just sort of picked a random point. But again, it's probably just a simple optimization sort of budgeting problem, right. I think.
And since you've started the operation, have you noticed some interest in Australia from other universities to look at your model and to perhaps mimic it and to build similar services at the universities?
Yeah. There's been a lot of interest, both internationally and nationally. I guess it depends on the senior leadership, right, of the university, really, at the end of the day, if they have the belief that this academic approach could work, right? The professional route is safe. You know how to employ staff on professional contracts. Their duties are well described. Their KPI are easy to set. And so building it as a professional workforce is sort of a conservative and safe route, which I think many of the universities is the appeal for many of the universities. So it really depends on the leadership of the university if they're willing to believe to take the risk or yeah. So University of Western Australia, I think, is building something similar to us, whereas RMIT have opted to go the professional route. So yeah.
Right.
Do you involve students? Yes, we accept interns. So predominantly master's students. We have an intern program where they come and work for us on an internship. Yeah. For a period of 10 weeks. We run a summer program and a winter program. That's actually been quite well done.
Perhaps we'll take one extra question from Adam Koscinski. Mind you, it's 1 o'clock in Melbourne for Professor Turpin. So
having so much fun, I haven't
past midnight. So let Professor Turpin rest a little bit before the next day. So what do we have here?
Adam, that's a very good question. I think a lot of the problems come to us very ill-defined. I mean, even worse than a software problem, right? So those of you who have tried to gather requirements from users for software know that it's fraught. I think where the data's involved, it adds an extra layer of fraughtness. People, we say in big bold letters, your data must be ready to go, right? When we come in and say, let's go with your data, that means many different things to many people. They may not have had, they thought, oh, do I need ethics clearance? There goes a month waiting for ethics clearance. Oh, there's missing values. I didn't realize that would be a problem. Oh, well, we thought all the names being in different formats would be fine. The data is a mess. It's missing. It's we can't touch it because of ethical reasons. It's a bit of a nightmare. And despite our best efforts, we've done 4 of these calls now, and we put it in bigger font and talk to them before shepherd their applications, and inevitably there's some hold up with the data. That's before we even get to what they want to do with the data, right? So yeah, they're quite ill-defined many times. Some people are great, who have experience, but a lot of them are very ill-defined problems. And
thank you very much. Thank you.
The fun.
Thank you, Professor Turpin. That was great. A very interesting talk. Completely, I must admit this also in the self-interest of our organization, because we are trying to learn from the best effort around the world, and yours is such an example. I wish we go in that direction. University of Warsaw might be sort of comparable to University of Melbourne in size and ambition, certainly. So it would be great to have that kind of support. Thank you so much for sharing your experiences and your knowledge in that regard. And let me remind everyone here that please check our website. Be aware that we will be running this very interesting conference in July. The deadline for submission of papers is approaching fast, but I want to encourage everybody, or perhaps you might know someone who is doing very interesting research worth communicating to our community. Please spread the word. You are all welcome. We have very wide support, sponsorship of our seminars. I acknowledge it and thank all partners and sponsors and supporters. Again, all our talks are recorded and are available for everybody to watch. So far, since we started, there were over 15,000 visitors who hopefully enjoyed the experience, and those who cannot participate or follow because, for example, of great time differences. That's another way of accessing this material. Of course, so we hope that we'll be able to publish Professor Turpin talk as well. And with that, I thank you all, and hopefully we'll have something interesting next month as well, although at the moment I don't know the speaker or the name or the topic. So watch this space. Thank you very much and goodbye.